Alright, we are going to continue our investigation into probability here at pre-calc, and this section is a little bit longer, so I gotta jump right into it. Okay, so go ahead and read this and see if you have any questions and bring any questions to me. But in exercise 1, we're going to flip a coin and then roll a six-sided die. So I think writing out the sample space would be helpful for some of you. So what we're talking about is sometimes we do the sample space with braces in here. So they're talking about like, okay, we can get tails in a 1. We can get tails in a 2. We can get tails in a 3. And after a while, it kind of gets boring, tedious. But I do think it's helpful. D5. Trying to squeeze it all right here, but I will go into the next one. Otherwise, you can get heads in a 1, heads and a 2, heads and a 3. So a few questions I could easily ask would be, well, how many different possibilities do we have? Because we will be doing probability just like what we did in section 9. There's 12, and that's because there's 2 options for a coin, and there's 6, and 2 times 6 from the fundamental counting principle tells us there's 12. So the premise, though, is writing out the sample space could help you understand this next step. So I'm using a highlighter to try and we want a head and a number that's less than 3. Now I know some people might argue if we want to include 3 on this one, but the word less than makes me say not equal to. So the way I'm going to do it is leave this as we had 2 possibilities, that's the desired, out of the sample space of 12, which gives me 1/6. And just like before, I'll let you leave your answer as a fraction. You can change it to a percent or a decimal. I'm good either way. As we go back to the answer key, again, feel free to write this out. But in part C, what they wanted you to do is ignore one thing or the other. So what they're trying to get you to realize is that there's probably a connection between letter B and letter C. And once we make that connection, I think you'll get the fundamental probability principle. But anyway, if you were asked to only find the probability of getting a head, ignoring the standard 6-sided die, well, the probability of getting a head is 1/2. There's 1 head and there's 2 options. And then the probability of getting less than 3, sometimes we write the problem this way, by the way. Well, there's 2 options. There's a 1 and a 2. And so that's 2 out of 6. And so in part D, they're saying, well, do you see a pattern between the 1/2 and the 2/6 that could give you this answer in letter B? And that answer is yes, there is a connection there, and that connection is through multiplication. That 1/2 times 2/6 equals 1/6, which is, and it's already written for you when you look at the next part, the fundamental probability principle. The important thing is these events have to be independent of each other. So what that means is that the probability of getting a head had no bearing on the probability of getting a number less than 3. They do not depend on each other. That's what it means to be independent. But once you get past that fact of understanding that events can be independent of each other, then you just multiply those probabilities, which is the whole point of 1D. So if you have any questions about what it means to be independent, feel free to bring them to class or email me, and we can set up some meeting that we can talk about what it means to be independent. And yeah, I'm going to go back to this. Okay. So we are dealing with binomial probability problems. We got introduced to this a little bit earlier, but I'm going to be using this again and kind of getting into it a little bit more in a little bit more detail here with it. So on a 5-question multiple choice test, there's 4 choices per question, and they want the probability of getting exactly 3 out of 5 questions correct. So in each one of these probabilities, what we have is a 25% chance, because there's 4 options. We have a 1 in 4 chance of getting the right answers on each question. And I know I've done a problem like this before, but now we're formally getting to it, and we're doing some more of these. What we could do is we could get the first 3 correct. So the first 3 are correct. We get 1 in 4, 1 in 4, 1 in 4. But then the next 2 we have to get incorrect. So that's a 3 out of 4 probability. But this is the only probability if we got the first 3 correct, because we didn't have to get the first 3 correct. We could have gotten the first 2 correct, 1/4, 1/4, and then maybe the next one wrong, and then the next one right, and then the next one wrong. But it doesn't even have to work out that way. So that's what we're trying to get at, is how many different ways could you actually do this? Because you could get correct, correct, correct. I'll put W for wrong, wrong, correct, correct, wrong, correct, wrong, correct, correct. And all I'm doing is just moving pieces along. You know, it could be correct, wrong, correct, correct, wrong, correct, wrong, correct, wrong, correct. And you might get exhausted thinking of all of the different ways of getting the answers correct and wrong. And there is a pattern that goes on. There's a few more, and if you want to exhaust all of those options, but I'm going to kind of ruin this for you, is that there are, let me see, there's 5 questions, and we want to get 3 of them correct. And it's a combination because we don't care when we get the answers correct. Okay, so the order doesn't matter. So that's the number of different ways that we can get these things, I'm going to put an arrow over here, correct. And that might kind of round out your understanding of this formula that we did a few days ago, where we did the p-value, the number, that's the probability of getting correct, versus the q value, we did this a few days ago, the probability of getting incorrect. Well, we want 2 of them to be wrong. So what I'm trying to get at is that we want to find this probability and then multiply by the number of different ways we can get that. And again, I'm kind of bouncing back and forth to the answer key because I want to make sure I cover all of my bases. So if I kept going, it would have turned out to be 10 different ways of correct versus incorrect. And I wanted to mention this, is the tilde sign in stats is used for not. So the probability of correct is 1/4, the probability of not correct is 3/4. So we can figure out that probability, but then there was 10 different ways of getting that, and we get the correct answer of 45 out of 512. That's your probability of just randomly guessing on a 5-question, 4-choice, multiple-choice question test, and that's your probability of getting a 60%, or 3 out of 5 correct. And again, you've seen this formula before. I like to introduce it to you a little bit early, and then we'll attack it a little bit more now. And I've been trying to do that a little bit more in this unit. And if it's a failure, then I can change, but I just want to try out something new. So here's a problem, exercise 3. It's probability of rain on any given day of the week is 2/3, so pretty rainy place. So what's the probability it will rain exactly 5 out of the 7 days? Well, we have 7 days. We want 5 of them, because it could be rain, 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 sunny, sunny. Or it could be rain, 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 sunny, rain, sunny. So this is the number of different ways that we can switch around the days. So then what we want is the 2/3 probability. So we want 5 rainy days. And then we want not rain. Well, the probability of not rain, and that's where this comes in, and sometimes I just assume you know, is it has to be the complement of this. Or not rain means it's 1/3. So 2/3 it will rain. That means 1/3 probability it will not to the second power. And I'm going to just hit equal, and I'm going to go to the answer key. I trust that you can use a calculator on this one. Because in letter B, the difference is we want it to rain on exactly one out of these days. So 7C1 times 2/3 to the first power, because we only want it to rain once, and then 1/3 to the sixth power. So a few things before going to the answer key, equal, is these two numbers right here must add to equal 1. And then these two numbers here, the 1 and the 6, have to add to equal this number. And you can verify that that happened over here as well. That 5 and the 2 add to equal this number. Yeah, so I'm going to jump to the answer key to save us a little bit of time on using a calculator. But I trust that you guys can use a calculator. And if you have any issues with the calculator, just bring them to class. I'll try to not, make sure that you understand everything. So this one's a little bit more likely to happen than this one. Not very likely to get exactly 1 day of rain. All right. And go back to my notes. So if at any point you need to pause the video and write anything down, feel free to do that or rewatch it. So here's another one where we're getting exactly 4 heads when flipping a fair coin 8 times. So we have 8 times that we're going to flip and get 4 heads. And notice that we keep using the word exactly because this is the formula that we use for exactly. There's going to be a slightly different one that we're going to investigate soon of, well, what happens if it says more than 4 heads, and things like that. So this one's kind of nice though, because the probability of getting a heads is 1 out of 2. And we want 4 of them to be heads. So remember that these two numbers need to add to be 1. So 1/2, 1/2. So that's the probability of not heads. In other words, probability of tails. And if we have 4 heads out of 8, we need to have 4 tails. The remaining 4 need to be tails. So again, go to your calculator. I would type this in. You could do this by hand, but some of you might be trusting your calculator a little bit more. You can see the formula. You can see how they get the answer. And then again, your calculator will reduce it for you to get option 3. I think I have enough time to do just one more, and then I'll start a new video. Again, feel free to pause at any point if you need to write anything down. If you want to practice the next one on your own, that's fine with me. Okay, so we have a free throw shooter, I guess an 80% free throw shooter. If she shoots 6 free throws in a game, what's the closest probability she'll make exactly 4 out of them? Again, notice that word exactly. So we have 6 free throws. I don't care what order she makes the 4. I'm just going to leave this as 0.8. You want to change that to a decimal, 80%, 0.8. We want her to make 4. And then remember, this other number needs to add to equal 1. So it's got to be 0.2. Well, if she makes 4, this is the probability of her missing 2. And then again, you can go to your calculator. How about this? I'll let you try number 6 on your own. This is how you set up number 5. And I'm going to jump to the answer key. So if you're ready, I'm going to jump to the answer key. So if you hit pause to try it on your own, cool. If not, here is the final 2 answers for exercise 5 and 6. And I'll come back with exercise 7 in the second video and try to finish out these notes.